think about the questions that I asked you yesterday? Yes or no? Yes. I'm kind of uncomfortable with people calling me sir. My students in Pune, ISER, you know what ISER is? Okay. That's where I teach. And there are 5 ISERs, one in Pune, one in Calcutta, and so on. And they have now started one in Tirupati. ISER focuses on basic science. IIT is for technology, and ISER is for science. I heard some kind of response an hour ago about science being technology. Science is not technology. There is, of course, a relation between the two, but science is not technology. So, for example, to make this, you need technology, but making this is not science. Making TV is not science, making TV is technology. Making atom bombs is technology, but for some technologies you need science. But the two are different. Science focuses on understanding the universe, and technology focuses on doing certain things, making products and so on, or procedures to make life, human life in particular, make human life better in most cases. Sometimes, of course, things like atom bombs and other things, they also make human life worse. There are also aspects of science which have no relevance to any practical use. So one of the things that scientists are extremely interested in is, what is the size of the universe? That question has no practical utility. Scientists are also interested in finding out what is the age of the universe. How can you apply that to anything? But some scientific pursuits have practical use, and technology uses those things later, but the two are not the same. It's like saying science uses math, but math is not science, nor is science math. So words like relation between math and science is exactly like the relation between these two. You have to keep them separate. You know about Michael Faraday? Michael Faraday, who did lots of interesting experiments on electricity. When Faraday was working on electricity, apparently the British minister visited him and said, this thing that you call electricity, what is the use of this stuff? And the minister was unimpressed. Why work on electricity? What is the practical use? And apparently Michael Faraday said, someday, minister, you're going to tax it. So Faraday was talking about this relation. There are some scientific pursuits whose practical applications may not be obvious at that time. It comes much later. In some cases, scientific pursuits have no practical application. So some of the questions that I raised yesterday may not have any practical application whatsoever. It doesn't matter for scientists and mathematicians. Okay, so the questions. Let me ask this question. One question that I had asked you was, if you think of a line, a finite line having a finite number of points in a math of that kind, can you bisect every line? Yes or no? Do you understand the question? If a line is composed of a finite number of points so that a longer line has more points than a shorter line, is it possible in that geometry to exactly divide a line into two equal halves? How many people say yes? Raise your hands. How many people say no? Okay, all right, so why do you say no? You don't have to stand, but you're welcome to. You can also fly if you wish. You mean if you have a line with 2 points, if you bisect it, it'll be simply 2 points, there will not be a line. Okay, so that line is not simply divisible to get 2 lines is what you're saying, right? Yeah. Okay, did everybody understand that? This is actually an interesting issue that you're raising. She's saying that there are lines in this geometry which are not divisible. If you divide them, you don't get lines. So for something to be a line, this is a point. The shortest possible line in this math will be a line being made up of 2 points. But if you divide it, each part is a point, not a line. And of course, you cannot divide a point any further. Yeah. But suppose you have that, your answer is absolutely right. But the answer that you're making is there exist lines which are not divisible into smaller lines. But notice that if you have, if you have a line like this, you can divide it. My question is, if you divide it, will the 2 halves be equal? Here, the 2 are equal, only they are not lines. But are there lines such that if you divide them, the 2 halves are not equal? Was my question. What's the answer? Exactly. So if a line has 36 points, you can divide them into 2 equal halves. But if it has 37 points, you cannot divide them into 2 equal halves. That is not the case in Euclidean geometry. In Euclidean geometry, any line can be divided into 2 equal halves. Okay. So that was one of my questions, and the other question was, what is a solid? Any answers? Oh, okay. So tell me, I wasn't here. I think I went out by then. What is a solid? Yeah? Closely arranged? Closely arranged? Yes? Definite shape. Yes? Movement of particle in regular. Do you need both or only one of them? Both? So, because you see, the reason I'm asking is, if you have closely arranged definite shape, if I ask about a dozen people to come here on stage, and we stand huddled together in a circular shape, is that solid? And if we move away, do we become liquid? Okay. Okay, when you get answers of this kind, you should not simply write them down. You should ask questions. It doesn't matter who is saying it, right? You should look for counterexamples. Okay, my question yesterday was not about solid versus liquid in terms of molecules or subparticles, but in terms of, no, not even that, in terms of our experience. Notice, for example, if you stand like this, right? I don't know anything about molecules, but one thing I do know is that I'm standing against something solid, right? You don't have to know about molecules. In fact, people in the 16th century, long before the idea of molecules came into existence, knew about solid and liquid. And I'm asking you about that basic stuff, primary school stuff. I'm not asking you about PhD level stuff. Yeah. Solid is rigid. Okay. So that means my shirt is not solid. Is that your judgment? Obviously, this is not rigid. Your hair is not solid because it is not rigid. So it's true that in rigid bodies that you cannot change their shape, right, are solid. So if rigid, it is solid. But the reverse does not follow. Not everything that is solid is necessarily rigid. Okay? So the reason why I judge this wall as solid is because it doesn't yield to my sense of touch. Okay. As I said, this is not something that you will be able to answer in a few hours or one day. So let me give you one more clue. Can a blind person, somebody who cannot see shape, tell the difference between solid and liquid? Yes? So obviously it is not the shape, it is something else. Yes? Yeah, exactly this. Right? So if I push, my hand is not going through. And if I push on that, my hand will not go through, so I say it is solid. But if there is a bucket of water, and I try to lean on the water, what will happen? My hand will go through. So I say, oh, that is not solid, that is liquid. But if that bucket of water is frozen, I can do that. I can walk on frozen lake, and I cannot walk on non-frozen watery lake. That's one clue. Think about that very carefully. The other thing is this. Some substances, if you change the temperature, they change their properties. So if you heat water, at some stage there is a transition from one state to another. So you discover that below 100 degrees, above 0 degrees centigrade, let us say, if I lean on water, my hand will go through. But if it is below 0, I can lean on it, and my hand will not go through. So there's a transition that happens during a region of temperature. If I raise the temperature, like 50 degrees, 80 degrees, 90, 100, then even the shape disintegrates. I cannot put water in a bucket if it is like 110 degrees centigrade. It will just be diffused in the room. Okay, you can use these basic ideas to come up with a definition of solid that you can put in a primary school textbook. Notice that in a primary school textbook, you cannot talk about molecules. You cannot talk about atoms because these are like, 7-year-old, 8-year-old kids. So you have to say this in terms of our experience, what you can see, what you can touch, what you can bite into, not molecules and electrons and photons, which are not visible, are not perceivable by our senses. So try to construct a definition that you can put into a primary school textbook. Okay, I'm leaving you with that. I'm not going to give you a definition. Instead, I want to invite you to consider something related to what we were doing yesterday. Yesterday, we were talking about the strategy of defining things, defining concepts in math and science. So we went through the process of constructing definitions and evaluating definitions. That's a very important aspect of math and science, and in fact, all academic subjects. Now I want to move on to categories and systems of categories. So if you say something like tree, that's a category. If you say horse, that's a category. If you say gold, that's a category. If you say table, it's a category. It doesn't refer to any particular table, but a group of things that you call tables. It's a class, right? When you say bottle, I don't mean this bottle or that bottle. I mean the class of bottles. So a number of things which can be called bottles. When you say human being, I'm not referring to me in particular or to one of you, but the category of humans as distinct from the category of horses. Now, a very important activity in math and science is constructing categories and constructing systems of categories, by which I mean related categories. So there is a category called square, and there is a category called rectangle. There is a relation between them. There is a category called horse, and there is a category called mammal, and there is a relation between them. But the category called gold and the category called horse, no relation. That doesn't belong to a classificatory system. That's the other word for it. Classification and classificatory system. That's what I want to discuss with you now. I want to begin by drawing your attention to the category called animal. What's the word for animal in Tamil? What? Vilangu. Animal. Okay. Vilangu. Okay. Like that? Okay. Now, is a rabbit a vilangu? Yes. Is a butterfly a vilangu? No. Okay. So, rabbit, yes. Butterfly, no. How about birds? Birds are not vilangu. How about worms? Are worms vilangu? No. Are humans vilangu? Humans are vilangu. Okay. Yes or no? Pardon me? All are? All are vilangu. You mean even those things? So there seems to be some disagreement among you. Some people say that birds and butterflies are not vilangu, and you're saying birds and butterflies are also vilangu. Ah, okay. What he's saying is, vilangu is animal. And these are animals. Therefore, these are also Vilangar. Okay, now, there are two words. In English, the word animal has an ordinary meaning in the ordinary English language, and it also has a special meaning in biology. So in ordinary English, before you are exposed to biology, humans are not animals, birds are not animals, fish are not animals, but cows and dogs are animals. This is ordinary English. In biology, however, all these are animals, including humans. So that's a different system of classification. Biology doesn't follow the meaning of animal in ordinary English. It changes the category. So let's call it animal 1 and animal 2. These are pronounced the same way, written the same way, but these are two different concepts, not the same concept. Two different categories. So the question that I want to raise is, why should we accept that meaning as opposed to this meaning? Why have one, not the other? Why did biologists decide that butterflies and birds and humans should be grouped under animal? What's the reason? Yes? Meta? Metazoans. Yeah, these are all categories that biologists have decided, right? Did you ask your teacher why should metazoans have, the animals should come under that category? So let's take this following thing, okay? Butterflies have wings, right? They fly. So why can't I say butterflies are birds? Mosquitoes fly, therefore mosquitoes are birds. Did you ever ask that question? So why can't I group flying things as birds? Okay, let me try to give you a way of answering questions of this kind. Why this category? Why not some other category? Consider Aristotle. For Aristotle, had this category, you have humans and non-humans. And under non-human, you have animal and plant. So for Aristotle, humans are not animals. The system that you have learnt in school in biology textbooks is you have plants. Oh no, let me do the same thing. You have animals and plants. And under animals, you have, let us say, vertebrates, you have mammals, and you have primates, and human. And humans, therefore, are animals, according to the textbooks that you have studied, but not for Aristotle. My question is, why should we accept this? Why not this? Yes? Motility? Yeah, but humans are distinct from animals. Human can speak. None of the animals can speak. So why don't you say ability to speak is different? Ability to do mathematics is different. So why don't I use this one then? And as far as motility is concerned, bacteria are motile, but you don't call bacteria as animals, right? Bacteria come under animals? Yeah, according to the old classification, but according to the current classification, bacteria are not animals, right? If you have the 5 kingdom classification, bacteria. So my question is, why should we accept one classification as opposed to something else? More detailed? This is equally detailed. That is not an answer. All that you're saying is that this is what you have learned in your textbooks. Saying that this is what you have learned in your textbooks is not sufficient, because what I learned in my textbooks several years ago was that all life forms are grouped into animals and plants. So I learned that bacteria are plants, amoeba are animals. I never understood why. Okay? And you do not understand the 5 kingdom classification either, because in some systems there are 5 kingdoms, in some systems there are 6, in some there are 4 different classificatory systems. How do you choose your classificatory system? Here is the answer. You need to specify the properties of these. So humans have a heart, humans have lungs, humans have limbs, but so do mammals and primates. If you say humans are primates, then all these characteristics would follow. Okay, I need to take a short break. Give me 5-10 minutes. I'll be back. Vignesh, can you take over? I'll be back. Yeah. The Earth. How are we going to find out? Okay. I leave you with that question, but I want to get back to the issue of classificatory systems. So the question that I had raised was about why should you choose the classificatory system that Carl Linnaeus set up, where humans come under primates, which come under mammals, which come under animals, versus Aristotelian system, where humans are not animals or plants either. One way of thinking about it is to take an easier question. So you will agree that here the sides are all equal. You will call it a square. And this one, you will not call it a square. You will call it a rectangle. Question, is this a rectangle? How many people would say this is not a rectangle? It's only a square, not a rectangle. Can I see some hands? One person. Anybody else? There are 2. So there are 2 people who say this is not a rectangle. This is only a square. Okay? And some of you say this square is a rectangle. Is that? Is this a parallelogram? Is that a parallelogram? All right. Is that a parallelogram? Oh, wait. Is that a parallelogram? What is it? Is that a quadrilateral? Okay, again, somebody might say this is not a quadrilateral, right? So there are two different systems of classification. Let me sketch both for you. You can say polygon, and you can say three-sided, four-sided, five-sided, etc. And a four-sided polygon is a quadrilateral. A quadrilateral can be a parallelogram or not one. If it is a parallelogram, then it can be a rectangle or not a rectangle. And if it is a rectangle, it can be a square or not a square. So that means a square is a rectangle, which is a parallelogram, which is a quadrilateral, which is a polygon. Another classificatory system would be a polygon can be three-sided, four-sided, five-sided, etc. And if it's a four-sided polygon, it can be a square, it can be a rectangle, it can be a parallelogram, or it can be a quadrilateral. What that means is that a square is none of those, a rectangle is not a parallelogram or a quadrilateral, and a parallelogram is not a quadrilateral. So I'm going to call this system A, and I'm going to call this system B. And most of you choose this one over this one. Why? What is the advantage in choosing one of these over the other? Now, I want you to think about it, discuss it with people sitting next to you, and give me an answer. Think first. I'll give you a couple of minutes. What is the reason? Ready? Okay. So, can you give me a reason to make a choice between the two? Who is going to give me a reason? Yeah. All the properties of square come from quadrilateral. Wait. Are you saying that you can predict, you can figure out all the properties of square from the properties of quadrilateral? All the properties? Or some? So notice that one of the properties of square is that all sides are equal. Another property is that all angles are equal. Can you get that from quadrilateral? You are on the right track. The way you are thinking is absolutely right. I think what you mean to say is this, that if you choose this system, Some of the properties of square can come from here, some other properties can come from here, and some other properties can come from here. Whereas if you choose this system, you will have to state it separately. So let me ask you, which properties of square can you predict, can you infer from quadrilateral? Four-sided. Okay, but that is true here. A square, a rectangle, parallelogram, quadrilateral are all four-sided. All the angles are 90 degrees? All the angles are 90 degrees? In here, all the angles are square, and where do you get it from? So all the angles of a square are right angles, but that comes from here, right? All angles are right angles. So you don't have to say it here. What else can you get? Yeah, sit down. Yeah? Opposite angles are equal. Opposite sides are equal. Where does it come from? Parallelogram. Opposite sides are equal. That will come from here. Okay, and opposite sides are equal, and opposite sides are parallel. You don't have to say it here, you don't have to say it here, but here you have to stipulate it separately, right? Anything else? Anything else that you can say? Can you think of some property of quadrilateral which will be inherited by this, by this, by this? Yes? Sum of, yeah, the sum of angles. The sum of angles is 4 right angles. If you say it here, and if a parallelogram is a quadrilateral, it follows that the sum of angles in a parallelogram is 4 right angles, follows that it is true of rectangles, follows that it is true of square. So the reason, now we can articulate the reason for choosing this over the other. If you choose this system, some of the important properties are inherited from the ancestors, from the higher categories. So you don't have to say it separately. Here, on the other hand, you have to stipulate each category, all the properties separately, which is unnecessary. And mathematicians would say, or the scientists would say, this is a simpler system. Simpler meaning you don't have to state things redundantly, unnecessarily. I don't know if you have heard the word Occam's razor. That also means the same thing. If you can get the results right with 4 statements, do not use 6. If you can do things with 6 statements, do not use 7. Okay, that's Occam's razor. That's also the same as simplicity. So you can get all these things inferred. There is a kind of inheritance in the system. That's the reason, and that is the major reason to choose between alternative classificatory systems. That is how you evaluate classificatory systems. Now let's go back. Okay, now the criteria are clear. Let us move from geometry to biology. The Aristotelian system of human, animal, plant, and you have vertebrate, and you have mammal, and you have primate, and you have chimpanzee here. And the other system you have animal, plant, and you have vertebrate, and you have mammal, you have primate, and you have chimpanzee and human. Can you give me reasons to choose this as opposed to that? What are the things that chimpanzees and humans have in common? Yeah? They have? Structure like what? 5? Spine. Yeah, okay. So you don't have to say that mammals have spine, that primates have spine, that chimpanzees have spine, humans have spine. Right? But here, notice that you have to say it here, but you have to now stipulate that humans also have spine. You don't get it free. Ancestry, forget about ancestry. I'm not talking about ancestry. I'm talking about classification. Because when Linnaeus proposed it, he wasn't thinking about ancestry. Right? So there are two kinds of biological trees. Let me make that clear. There are two kinds. There is a classificatory tree, and there is an ancestry tree. This tells you, the ancestry tree tells you about evolution. So humans evolved from primates, evolved from mammals, and so on, and ultimately from monocellular organisms. That is ancestry. And the word that biologists use is phylogenetic tree. That tree is of a more recent idea. When Linnaeus proposed this system, he wasn't thinking about evolution. He was thinking about classification, and the word for this is phonetic, pure classification. These two should not be mixed up. These are two different notions. This one is talking about categories, classification, whereas this one is talking about ancestry. Two different trees. Okay? There is some degree of convergence, but the trees are different. Most biology textbooks confuse these two. So it's important to keep them separate. Okay, what else? What else can you predict or infer from this tree, but not from this tree? What else can you infer? What other properties of human can you predict? By which what I mean is, can you infer without specifying? Yeah. Humans are? Humans are mammals, but that is what the tree is claiming. But this one is saying humans are not mammals. So what is the advantage in saying that humans are mammals? Is my question. Yeah, humans give birth. Okay, so whether mammals give birth to humans, give birth to children as opposed to laying eggs. And so it follows that primates do and humans do, and chimpanzees do. Yeah. Okay, so animals depend on plants or other animals for food. And that is true about all these guys. But again, it is true about humans, but that doesn't follow from this tree. Okay, and then so many humans have lungs. You don't have to stipulate that. It comes from here. Humans have heart. Comes from here. All the properties of humans, almost all the properties of humans will have to be stipulated as idiosyncratic properties here, but they are all predictable, they are all inferable in the other system. That is why we choose this as opposed to that. Okay? Not because that is what the textbook says, but because you have looked at the reasons and you consider this to be better on the basis of the reasons that you have identified. Not because your teacher says so, not because the textbook says so, but because you judge it to be better with adequate reasons. It's your responsibility to accept or reject what the textbook says. Okay, is that clear so far? The reasons for choosing one system over the other. If it is not clear, raise your hands. If it is clear, raise your hands. Okay, good. Now, birds are creatures that can fly, right? If you define birds as creatures that can fly, then mosquitoes, butterflies, bats, and parrots are all birds. Pardon me? Yeah, I'm saying if you define birds this way, all of these are birds, not just parrots. Yeah? Did I say are not birds? No. I said all these are birds. Not merely parrots, but all these other guys. But the other one would be birds and non-birds. Parrots are birds. This is what your textbook says. Mosquitoes, butterflies, and bats are not birds. Right? Why accept this? Why not this? Doesn't this look much better? Yeah. Birds? No, that is not true. Not all birds are feather. Butterflies, for example, do not have feathers. You see, you cannot assume that this is the right classification. You have to give me a reason to choose this as opposed to that. So don't try to give me a reason today. This is not easy. So once again, I'm going to leave you with this question. Think about it. You will get a day to come up with an answer. Because your learning happens not when you're sitting in the classroom. Learning happens when you're outside the classroom, when you're thinking. What happens in the classroom is only an initial trigger to let the learning happen later. It may happen when you are half asleep. It may happen maybe, a week from now, when you're all gone back. So that is the important part. So I'm going to leave you with this question, and we can, if possible, discuss it tomorrow, but maybe not. Okay, questions? Questions from you? Yeah. Penguins? Penguins obviously are not birds because penguins cannot fly. What about? Ostriches? They cannot fly, therefore ostriches are not birds. See the problem? I'm just being consistent with this definition. Any other questions? So you have to figure out why it is a good idea to say ostriches are birds. Because from my definition, it follows that ostriches are not birds. Yeah. Solid. Okay. Very good point. Absolutely right. So sugar, you can do that with sugar. Sugar is pourable, right? Like water, you can pour sugar. Powder, for example, the wheat atta, the wheat flour, you can pour it, but you wouldn't call it liquid. Okay? Yeah, I'm not going to give you a solution, but all I'm saying is that this is a good point to make. You have to consider that. So that adds to your discomfort. The right example to choose. Yeah, but I won't help you with it. Let me give you a peculiar case about this business of solid and liquid. So we said something like, if it is liquid, if you try to stand on it, you will sink, right? But if it is solid ice on a lake, you can walk across. Now, I want to tell you something about some peculiar facts. There are certain lizards called Jesus lizards. Jesus lizard, you can do a you can do a YouTube search for Jesus lizards. Jesus lizards can run on water, but they cannot stand on water or even walk on water. They will sink. But if they run, they will not sink. Problem number one. Problem number two, I'm not sure about the name of this thing. Ubilix? Okay, there's a special word for it, but if you take something like maida and put it in a bathtub and make some kind of mixture, liquidy mixture, if you stand on it, you will sink. But if you keep jumping, you will not sink. Is that liquid or is that solid? If you jump on it, you can do this with, you can do a Google search for it, or you can do a YouTube search, and you will see there's people jumping on it. Right now, I cannot remember the special name for it. I'll try to give you the name. If you do a Google search for, YouTube search for jumping on batter, you might get the word for it. So this is like Jesus lizards. You can't stand on it, but you can jump on it. Okay. How many states of matter are there? 4. 5? Okay. Other two are? Right. So which is the true one? 3 solid, liquid and gas, or also should you also include plasma? Why? When somebody says there are 4 states of matter, you should ask, why should I believe you? Don't accept it. Maybe they have some good reasons to say 4 instead of 3, but don't take it lying down. If you want to be scientists, the very first step is asking the question, why should I believe you? If you blindly accept what your textbooks and teachers say, you will not become scientists. I mean, you will not become scientists in the true spirit of science. What are the 5?
Somebody said 5, right? So what is the 5th one?
4?
Both science, that's it.
Okay. How about 6? How about this thing? This is the 6th one. Or, for example, there is a distinction between solid and liquid like water, and matter is in between, right? Semi-solid. That is the 7th one. So you should ask, why? Okay, other questions? More questions? All right. So, yeah.
In the case of solids, you can bind it up, you can form heat.
Yeah.
Then in the case of liquids, you cannot form heat.
Yeah. But you can make a spherical shape, right? If you put a drop of mercury on the floor, you get this kind of, not a heap necessarily, but you get a certain shape. And not all solids can be made into a heap, right? For example, if you take a stone, it doesn't become a heap if you put on the floor. It becomes a heap only if it is powdery.
A lot of stones can form a large.
Many stones, but not one stone. So is one stone not solid? Yeah. So the ability to form a heap is important for broken pieces of solid. But you still haven't got to defining solid. So we are still in trouble, right? Okay. Let me ask you a very unrelated question. This has nothing to do with classification, but it has something to do with what textbooks say. You have seen this sentence. Right? In your biology textbooks, you find a sentence. If you take the chapter on reproduction and heredity and reproduction, you will find a sentence that acquired characteristics cannot be inherited. Is HIV acquired? HIV. It is acquired, right? Can HIV be inherited from the mother to the child? Yes. So is this true? Okay. Do you see the problem? HIV is an acquired characteristic. HIV can be inherited. Is this true? Of course, you have to define what you mean by acquired and what you mean by inherited. Otherwise, this sentence doesn't make sense. So anyway, whichever way it is, HIV is a problem, and I leave it to you to solve the problem. I assume that the difficulty is clear. The answer may not be clear, but that is hardly ever the case. Any questions? Okay. Tomorrow, before I leave, I'll give you more things to worry about. As I said, the teacher's job is to get students more and more worried and more uncomfortable. The degree of discomfort will keep increasing. Okay, time for lunch.